Hello everyone, this is Steve, thanks for watching. We're going to keep on solving for x. So in this video we are going to solve for x in these equations by using the property of condensing logarithms to make it so we have a single logarithm equals a single number, and then we will rewrite in exponential form. So the base needs to match, and it does matter on these what the base is equal to. You'll see why in a moment. Let's do this first one. So you see we have two logarithms over here, and there's a plus sign in between the two. So we can combine the two logarithms into one logarithm using the product property. So log of x times x plus 15. That's the product property or product rule that we use to combine them. And then if we want to, we can distribute the x inside these parentheses, giving me x squared plus 15x. Now we can't just strip away the logarithm because we don't have a logarithm equals a logarithm. We have a logarithm equals a number. So we have to rewrite this in exponential form. Now even though you can't see it there, the base on this is 10. So we rewrite this as the base to the exponent, which is the number on the other side, 2, equals x squared plus 15x. Now we're not there yet because we have a quadratic and we have to set the quadratic equal to 0. So 10 squared is 100. So what I will do is I will subtract 100 from both sides. Now you could use the quadratic formula or completing the square here, but this actually can be factored as, let's see here, I think it's going to be x minus 5, x plus 20. So we ask ourselves, what are the values that make x minus 5 times x plus 20 equal to 0? Well, the answers are going to be 5 and negative 20. So we get x equals 5 and x equals negative 20. But then if you check these in the original equation, you'll see that 5 doesn't cause a problem because we end up taking the logarithms of two positive numbers, but negative 20 does because we end up taking the logarithm of negative 20 and negative 5. So negative 20 is a bad answer, and we must reject that answer, and the only answer we get for this problem is x equals 5. And that one is done. 5 is the answer, and the only answer. Moving on to the next one, once again we must combine these into a single logarithm on the left-hand side. We have another plus sign right here, so we will do the product rule again here. So we get log base 3 of x plus 5 times x minus 3. This is the product rule, the product property. And then we go ahead and FOIL that out on the inside here, so that's going to be x squared plus 2x minus 15, if you FOIL it and collect like terms. Then we rewrite this in exponential form. Base is here, the power is here, so this is going to be rewritten as 3 squared equals x squared plus 2x minus 15. Doesn't do any good to have the x squared plus 2x minus 15 factored because we don't have a 0 on the other side. So 3 squared is 9. This is actually a 9, we all know that. So therefore I will subtract 9 from both sides. So I'm going to get 0 equals x squared plus 2x minus 24. Because negative 15 minus another 9 is negative 24. Factor it now because it's set equal to 0 and it will do us some good. So we get x, let's see, I think it's going to be plus 6 and minus 4. Meaning we get the two answers of x equals negative 6 and x equals 4. Negative 6 is not bad just because it's negative. The reason negative 6 is bad is because when we try to plug it in here for x, we get negative 6 plus 5, which is negative 1, and we cannot take the logarithm of negative 1. So we reject our negative 6 answer. 4 is okay, because if you plug it in this first one right here, then you get 4 plus 5, which is 9, that's positive. And right here you get 4 minus 3, which is 1, which is positive. So 4 is okay, and it is the only answer to this problem. X equals 4. We had to reject the negative 6.